So this question concerns Newton's third law, which clearly states that equal and opposite force but on different objects. So for example, we have a book which is lying on the table. So this book experiences a normal force upward. As a result, this book also applies another force which is equal in magnitude and downward. And these two forces comes in pair and they are equal and opposite but act on different objects. Hence, the option number A on the same object is definitely wrong, right? So we can get rid of option A and C. Now, in order to clarify, the best way of doing this is by drawing a free body diagram when this to load and the cart is right here. So let's draw that. Basically, this is the cart and the load, and this is our surface. Okay. So for this one, there will be a gravitational force mg, and let's say this is A, this is B. So there will be a normal reaction from B on A. So this is for the load on the cart. This normal reaction which is going to act from B to A will be reversed, and it will be normal reaction on A by A on B. Okay, and these two will be equal in magnitude. Okay, then it will of course will have its mg. Both of them are the same mass mm, so that's fine. And then this surface is also going to apply a normal reaction on top of it. So this is a normal reaction on B by the surface, and this surface is going to experience a force which will be a simply normal reaction on surface by B, and these two will be equal in magnitude, right? So now look at the options which are available. The normal force exerted on the load by the cart, the load and the cart. This is the normal force exerted on the load by the cart, and the gravitational force exerted on the load by the earth. Because they are equal and opposite, though they are equal and opposite here, but by the Newton's law, when we are looking from the third law perspective, this is not true, right? We want this to be equal to this. Okay, so this is also not true. I'll get rid of this. The normal force extended on the load by the cart and the normal force extended on the cart by the load, right? So this is what they are referring to, these two forces. And because they are equal and opposite and they are different objects, this looks correct. So let's also look at number E. The gravitational force exerted on the cart by the earth, okay, which is this one. And the normal force exerted by the hill on the cart. This is the normal force exerted by the hill of the cart, right? Are not actually equal because this one is always there. So the correct answer here is D.